Did you know India has the highest railway bridge in the world? It's even bigger than Eiffel Tower. Let me first introduce myself. Hello everyone. My name is Ashutosh Kumar. I am a civil engineering student at BIT Meshra. On this channel, I will be explaining about various and different kinds of infrastructure related projects and I will be explaining the engineering behind them. In this video, I would be talking about the Chenab Rail Bridge, which is located in Jammu Kashmir. It connects Udhampur, Srinagar and Baramulla together. You might be wondering why this bridge is so much important. Let me tell you, it connects Jammu and Kashmir together in the northern India. Not only that, it connects the rest of India with Jammu and Kashmir. If you have forgotten, Jammu and Kashmir both how much beautiful they are, and if the amount of tourism this project will bring to this region of India will be immense. Building this railway bridge was not easy. First, and it's a fact, it took almost 2 decades to form this kind of bridge. And behind this bridge, the major achievement was of Dr. Gali Madhiv Latha, who is a geotech professor at IISc Bangalore. And as an Indian, you should know what an IISc Bangalore is. It's a research institute which is present in Bangalore, and its QS ranking is way good, and sometimes it even ranks higher than IIT Bombay in terms of QS ranking. The first major challenge was the extreme terrain of this region. The bridge has to cross a deep gorge, or you can say a deep narrow valley of a Chenab River, with the deck of the bridge located at about 359 meters above the sea level. The surrounding mountains are extremely rugged, steep and irregular, leaving no flat ground for construction purpose. To overcome this problem, engineers designed a massive steel arch bridge that can span the entire valley without requiring many supports in the middle. This design allowed the bridge to connect the two mountainsides safely across the deep gorge. Joining the two mountainsides without a huge gap is an extraordinary engineering achievement. The second challenge came from the complex geology of Himalayas. The Himalayan mountains are considered young, which means the rock layers are often fractured or unstable. Those of you who don't understand what rock layers are, over thousands or millions of years, different materials such as sand, mud, minerals, or volcanic material accumulate together and solidify. Each time period creates a separate layer, and these layers stack on top of each other. The problem is, mountain is not made up of single solid rock. They consist of many layers formed over millions of years. Some layers are strong while others are fractured or are weak. Engineers must study layers carefully before building the large structures like bridges. These uneven layers made it very difficult for engineers to build a strong and a reliable foundation. Engineers carried out extensive geological investigations before the construction. They drilled deep into the mountain and anchored the foundations of a stable rock formation to ensure that bridge would remain secure for n number of decades. It is claimed that bridge is designed to last for almost 120 years. Another serious problem was a strong wind acceleration. I have just stated that bridge is almost 359 meters above the river level, so you can just imagine how much height it is. It creates two major problems. The first is wind acceleration. The speed of the wind, or you can say the speed of the air moving through the narrow valley, is so high that it is similar to the air passing through a nozzle. The second problem is a large exposed structure. The bridge arc or deck are exposed to a strong lateral force, which can cause vibrations, oscillation, and structural fatigue if wind forces are not controlled. The famous example is Tacoma Narrow Bridge, which collapsed due to wind-induced oscillation. To solve this problem, engineers used aerodynamic design and conducted wind tunnel tests to understand how wind would interact with the bridge. The steel arch structure was carefully designed so it could remain stable even during the strong winds. The Chenab Rail Bridge is designed to safely withstand the wind speed of 266 km per hour, which is extremely high. For comparison, You can say the maximum wind speed in strong cyclones is usually 150 kilometers per hour to 200 kilometers per hour. So designing a bridge which can resist like 266 kilometers per hour of a wind is a remarkable achievement by our engineers. The fourth challenge was a risk of the earthquake. The Chenab Rail Bridge is located in a seismically active region of Himalayas, meaning the structure had to design to withstand a seismic forces. Engineer used a special design and flexible component so that the bridge could absorb and distribute earthquake forces without suffering major damage. The bridge is designed to withstand earthquake of magnitude of up to 8 Richter scale. To achieve this, engineer used flexible structural system, high strength steel and deep rock anchored foundation that help to absorb seismic energy. Transporting construction material to the site was extremely difficult. The bridge is located in the remote mountain region where roads are narrow and windy. Delivering massive steel component, construction machinery, and other materials require careful planning. Our engineers built temporary access road and used specialized transport systems to bring materials safely to the construction site. Finally, the construction itself had to be carried out at extreme heights over the valley floor. Workers had to assemble large steel sections hundreds of meters above the river, which created serious safety risks and required extreme precise construction. To challenge, engineers use a cantilever construction technique. The steel arc was generally built from both the sides of the valley until the two halves met in the middle, forming the complete arc structure. One of the most fascinating part of building the Chenab Rail Bridge was the extreme precision required when joining the two halves of the steel arc. Because the arc spans hundreds of meters across the gorge, even a tiny measurement error could lead to a major alignment problem. To solve this issue, engineers used advanced surveying instruments and computer modeling monitor every segment during construction. When the two sides finally joined, the alignment error was only in a few milliliters, demonstrating a remarkable precision involved in building this bridge. This is a true example of a modern engineering techniques. The instrument and technology used today are incredibly precise. Despite all these challenges, Chenab Rail Bridge stands today as one of the greatest achievements in modern engineering. It demonstrates how careful planning, advanced technology, and determination of engineers can overcome the most difficult natural obstacles. The Chenab Rail Bridge will not only connect Jammu and Kashmir more effectively with the rest of India, but it will also bring a major infrastructure development and economic opportunities to this region. This is truly an engineering marvel. Big shout out to engineers, designers, scientists from IISCs and IITs and from other reputed institutes of India and of other parts of the world